I've been always enthralled power of the ocean. I am fearful of sharks, but I love to get real close and look at them and try to pick out features on their body. I was testing panels in Hawaii at Pearl Harbor. The entire group of scientists in the Navy program were there looking at panels. My panels were early designs. The algae was the thing that the Navy wanted me to stop. When I saw the first picture of the skin, was exactly what I was trying to design. So through trial and error, we came up with this Sharklet pattern, and it's difficult to see on here, but the size of those features that make up the diamond are 2 microns wide and at most 16 microns long. Antibiotics and some of these compounds they've been using actually just kill off the weak bacteria. They let the strong ones survive, and that leads to superbugs. Sharklet doesn't do that. We inhibit them all.
On this, you can see the diamond pattern is here, and just with this model, first of all, the pattern itself is hydrophobic. So bacteria can't go where there isn't moisture. They're largely carried in droplets after a sneeze or the sweat on your hands when you touch a doorknob. When the water or the fluid that carries a bacteria dries, so it evaporates off of the surface, the bacteria get down into the grooves, kind of the valleys in between the features. And then when you go to touch that surface, your hands or whatever's touching the surface can't interact with the bacteria very well. So you're limiting the transfer of the bacteria back off of the surface.
It's really important to realize that we need bacteria to live. Bacteria are a very important part of our entire gastrointestinal system, our stomach. It's when things get out of balance that you get sick. But antibiotics, for example, they just kill everything is the goal. They kill all the bugs.
My name is Chelsea Magan, assistant professor in the departments of medicine and bioengineering here at the Anschutz Medical Campus. Antimicrobial characteristics are very important for medical devices because people go to the hospital expecting to be treated and leave healthy. Unfortunately, many people go to the hospital and end up with an infection. So in the United States alone, there are nearly 2 million hospital-acquired infections every single year. This is a huge problem. Right now, medical devices are given a bacterial or an antimicrobial characteristics through large amounts of antibiotics and silver particles actually being added into the device itself. When you do that, it increases the amount of bacteria that are killed by medical devices, very similar to overusing antibiotics. And it could create more and more of these superbugs that are causing antibacterial resistant infections. So the Sharklet micropattern does this by creating a non-toxic microenvironment where the bacteria just don't attach to the surface. It doesn't kill the bacteria, so Sharklet would not be contributing to making more and more superbugs in the hospitals.
We effectively created the urinary catheter, which is commercially available. We've created endotracheal tubes, feeding tubes, and wound dressings.
So when patients are hospitalized, up to 25% of them receive a urinary catheter. In the United States, this results in almost 1 million infections every year that are related to that catheter being inserted into the patient. And these infections, of course, lead to worse comorbidities and sometimes even death. So having the Sharklet pattern on a urinary catheter helps to reduce this burden by twofold. One is the Sharklet micropattern helps keep bacteria from attaching to the surface, but it also helps keep bacteria from migrating up the catheter and into the person's bladder. They show really nice preclinical data that the Sharklet micropattern was able to reduce bacterial colonization on the surfaces, and this was colonization of pathogens like E. coli and Staph aureus that people tend to acquire these infections of these bacteria in hospitals, and it was able to reduce migration of those pathogens up to 80%.
We have over 38 standard test methods within Sharklet that we use to demonstrate efficacy.
When you have a medical device implanted for a week or more, you want to definitely have less pain associated with the use of that product. One of the exciting things about Sharklet is that patients who are using our medical products, like our catheter, experience less pain.
It would be incredible to live in a world where Sharklet was on all of our consumer products and medical devices, because I feel like if that happened and put Sharklet on every surface that we touched, I believe we would impact millions of patients every year, and that could lead to billions of dollars saved in healthcare costs globally.